Okay, this is the Chemistry Chapter 9 review video. Alright, and what you're going to need for this video is the extra, in fact there's a third extra on it, but you get this off of Microsoft Teams in the file section, the extra review problems. We're just going to work 9, 10, and 11. You'll want a periodic table handy, and you'll want your notes from Chapter 9 handy. You're going to be referring to this chart. Mine's got checks all over it. Hopefully yours isn't that messy, but you're going to be referring to this chart of polyatomic ions. You will get a chart of these on the test, so you do not have to memorize them for this test. We will have to memorize them in the future, but not for this test. Alright, and I have made a printout with larger fonts so you can see it. So the first, number 9, the first one says, give the chemical formula for magnesium chlorite. Alright, so we'll call this A, magnesium chlorite. Aluminum sulfate. Okay, and then we also want to do lithium chromate. And finally, for the last one, number 9, ammonium carbonate. Okay. So magnesium is in column 2. It's a metal. It wants to give away 2 electrons since it's in column 2, so a 2+ charge. Chlorite, let's use your chart. So we'll find chlorite. It is ClO2 minus. So after the big switch, you would have Mg ClO2 2. We're going to take that 2 and put it down here on chlorite, and then the 1 goes with magnesium. All right, aluminum sulfate. So aluminum, you might have all these kind of memorized by now with all the Chapter 8 work. We're in column 3. It's a metal. Wants to give away 3 electrons. If it gives away 3 positive charges, 3 negative charges, it'll develop a 3+ charge. Now looking at your chart, sulfate, SO4 2 minus. Okay, so after we take the superscripts and make them subscripts and switch, it would be Al2 SO4, and because there's more than one of them, we need to put parentheses around it, and then that 3 goes right there. That 2 goes right there with aluminum. All right, lithium chromate. If you'll look at lithium on the periodic table, it's in column 1, has 1 valence electron. It wants to give it away because it's a metal. That'd give it a plus charge. Chromate, let's find that. CrO4 2 minus. All right, we're going to bring that 2 down here beside the lithium, and then the 1 will go with chromate. We do not need a parenthesis around it because it's just one of those. And then finally, the ammonium is on your table. On page 1 of your Chapter 9 notes, it's NH4 plus, carbonate, CO, and if you find carbonate, you'll see that it is CO3 CO3, 2 minus. All right, it's in the second column. This is ammonium's in the first column. So we have NH4, and we're going to bring this 2. That 2 goes with the NH4 now after we switch, so we're going to have to put parentheses around that. And then CO3, there's just one of those because we have a 1 charge here. So CO3 does not need the parenthesis because that 1 goes right there. The 2 goes right there. All right, so those are the formulas. You also will have to potentially go backwards. You're given the formula and you have to write out the name. Okay, so be able to do both. I believe some extra practice problems will give you some practice doing that. If not, the practice problems will. All right, that's number 9. Pause the video if you need to. Number 10. It says, give the name of the... Oh, well, here we go. Just what I was talking about is found in number 10. So we have BaCN2. Well, Ba is barium. If you'll look on the page 1 of your notes in the chart, right, Cn is cyanide. All right, so barium cyanide. The second one we have is AlOH3. You know that Al is aluminum. OH, look at the table, it is hydroxide. All right, NaC2H3O2. Na is sodium. C2H3O2, okay, find that on the charts in that first column at the bottom. That is acetate. Now you're going to have a chart with you, so any spelling mistakes will definitely not be tolerated. We would have a K2CrO4. Now these are ionic compounds, so we don't have to say dipotassium. It's ionic. We don't have to use that. So it's just potassium for K. And then CrO4 is chromate. All right, just find it in the table. It's in your second column. All right, CrO4 chromate. All right, and then the last one, NH4 2SO3. Well, NH4 is in column 1, and it is at the top. It's the first one. That is ammonium. Now, SO3 is not sulfate. Be careful. It is sulfite from the table. So near the bottom at the second column. All right, so that's pretty. If you have the chart, this is a super easy problem to do. But remember, you don't say aluminum trihydroxide. No, it's just these are ionic compounds. It's not barium dicyanide. It's just barium cyanide. The ionic compounds only form in one way, so we don't have to use those prefixes like we did in chapter 3. And finally, let's draw some shapes. And we'll also, on this number 11, decide, will this dissolve in water or not? Okay, the first one is Si2. Sulfur, of course, in column 6. Iodine is in column 7. So iodine can only take single bonds. All right, so if you have a sulfur in the center surrounded by 2 single bonds for iodine, it's going to make a bench shape. Okay? All right, so it would be like this. Let's go ahead and put those electrons. Name the shape. And the bond angle is 105 degrees. So while we're doing this, let's also decide, will this dissolve in water? So I'm not really sure which one is more electronegative, sulfur or iodine. I believe it's sulfur. It doesn't really matter. The bent shape is always polar. The charges don't cancel out. Okay, so always going to be polar, so it will dissolve in water. So yes, dissolves in water. All right, like dissolves like. Okay, so if it's a polar compound, the charges don't cancel out, then water's also a polar compound and it will dissolve in water. I know the question didn't ask that, but you absolutely will get asked these kind of questions on the test. All right, let's look at the second one. All right, we have CH2S. All right, carbon's always in the center, right? And each hydrogen has one, and then sulfur 1, 2, 3, 4, 5, 6. So we have two of these hydrogens. Each hydrogen can take a single bond. That's all it has room for. But the sulfur can take a double bond. So what shape has two single bonds and one double bond surrounding the center? Well, it is the trigonal planar. Okay, two single bonds, that'd be with a hydrogen, carbon in the center, and then the double bond will go with that sulfur. All right, so you can do something like this. It's okay if you put your sulfur on top and your hydrogens elsewhere. Don't forget those two electrons. So they all have 8. The shape is trigonal or trigonal planar. The bond angle, can you remember that? I'll give you a second. 120 degrees. So a circle's 360, so a third of that would be 120. Okay, will it dissolve in water? All right, well, the answer is yes, it will dissolve in water. It does have polar bonds. So this molecule doesn't cancel out, so yes, it will dissolve in water. Okay, and you don't really even have to know that sulfur is more electronegative than carbon. You just know that these don't cancel each other out. Okay, so it will dissolve in water. We should have some, hopefully, that'll cancel each other out. I'm not really sure. Maybe in this example we may not. All right, so let's look at C. That is PBr3. All right, we have phosphorus. That's in column 5. Bromine is in column 7. Each bromine can take a single bond. That's it. It just wants one more electron. So I've got a central atom, phosphorus, surrounded by 3 single bonds. So what shape is a central atom surrounded by 3 single bonds? All right, well, I'm going to have to fix this one, but it is pyramidal shape. Central atom, 3 single bonds. Pyramidal. So we would have bromine. Remember, to show the 3D effect, you put the fat line out front, bromine, and then a dash line. Don't forget that electron pair that's right there. Put it there. Let's get all these electrons added. All right, and this, of course, we call pyramidal. You got to write that down, pyramidal. What's the bond angle? Can you remember? Can you remember? Can you remember? Can you remember? Pyramidal? 107. Will that dissolve in water? Well, is bromine more electronegative than phosphorus? I'm not really sure. I do know they're different. Okay, they are different. So we can say that bromine is. It could be the other way, but this molecule is going to move, right? It's going to move down or it's going to move up. So it is polar covalent, right? As were the last two, and it will dissolve in water. Okay, pyramidal always dissolves in water. Always polar covalent. Okay, 2 more to go. D. All right, we have SiCl3I. Okay, silicon in column 4, that's going to be our central atom. It has 4 unpaired electrons. So 1, 2, 3, 4, 5, 6. Each chlorine in column 7 has 7, and each iodine in column 7 has 7. What kind of bond can chlorine take? It's the only kind of bond it can take. Single. How about iodine? Single. It's got 7 electrons. If you give it more, it's got too many electrons. So I've got 3 of these chlorines. So 3 chlorines, 3 single bonds with chlorine, and 1 single bond with iodine. Okay, so if I have a central atom surrounded by 4 single bonds, what's the shape? What's the shape? What's the shape? What's the shape? All right, tetrahedron or tetrahedral, whichever you prefer. All right, so let's put silicon in the center. What do you want to do? Let's put the chlorines at the bottom. But it doesn't really matter how you want to do it. Maybe you could put iodine right there if you prefer. But I'll put the iodine on top. So we got doink, 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 doink. Doink, 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 doink. Bop, 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 bop. Vut, 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 vut. Vut, vut. All right, so I know that these aren't going to cancel out. Now, if there was a chlorine up there, it would. It'd be even Steven. It would cancel out and it would be purely covalent. But it's not, because iodine and chlorine are different. So chlorine's more electronegative. This thing's going to move downward. All right, the chlorine's going to pull it all downward. It's more electronegative. So the shape is tetrahedron. What's the bond angle? Can you remember? 109. All right. Is it polar or purely covalent? We just said it's polar. So will it dissolve in water? Yes. Like dissolves like. Polar dissolves polar. It will dissolve. All right. That's our 4th shape. Last one. You're saying, I'm glad. CSO. Sounds like, a company that makes fencing or something. I don't know. Chemicals. CSO. All right. Carbon. Doink, 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 doink. Column 4. Sulfur. Column 6. 1, 2, 3, 4, 5, 6. Oxygen. Column 6. 1, 2, 3, 4, 5, 6. All right. Well, what kind of bond can sulfur take? Well, it has 2 open slots. So it could take a double bond. How about oxygen? It could also take a double bond. There's only 1 of them, so it needs a double bond. So we will put carbon in the center of a double bond with oxygen, a double bond with sulfur. All right, and then we have that and that. So Vesper theory says these outer shell electrons are trying to get as far away from each other as possible. So in this particular case, we want the shape that would get them farthest away is this shape. It's linear. So we have a central atom, carbon, surrounded by 2 double bonds. All right, so oxygen and sulfur have different electronegativities, so they are not going to cancel out. It will be polar, all right, but doesn't cancel out. So I didn't give you a purely covalent example, but you will get example of those in the Chapter 9 extra practice problems. So this is polar. So what is the shape? It's linear. What is the bond angle? 180 degrees. So on the test, you'll have to draw the shape, but you also have to tell me the name of the shape and the bond angle. If not, a lot of points will be taken off. Don't let that happen to you. All right, will it dissolve in water? Yes. Polar dissolves in water. All right, that's a pretty good review of Chapter 9. Now you should be able to do the Chapter 9 extra practice problem, so that is your homework. And that'll be a great review for the test, and I will talk to you next time.